for joining us today. As I mentioned before, this is our 9th splashdown of the multi-source session. So it's very exciting for us to have you here and to have you in these sessions. We see familiar faces from other sessions as well, new ones. This is also very, very nice to see. Yes, we are excited also to share with you two of our speakers today, Robert McDonald, or Rob, and Giulio Conte. First of all, this session today, we are going to explore how nature-based solutions can address water quality challenges while also contributing to biodiversity and ecosystem resilience. So Rob, he is a lead scientist for nature-based solutions and lead scientist for Europe at the TNC, the Nature Conservancy. He researches the impact and dependencies of communities on the natural world, studying how nature can increase resilience in the face of climate change and improve human health and well-being. He holds a PhD in ecology from Duke University and has published more than 100 scientific publications and 2 books. Prior to joining the Nature Conservancy, he taught landscape ecology at Harvard's Graduate School of Design, helping architects and planners incorporate ecological principles into their projects. As far from Giulio, Giulio is a biologist, freelance consultant, and one of the founding members of IRIDRA. Has over 30 years of experience in environmental analysis. He worked for the Lega Ambiente, an NGO in Italy, and Ecomed of the municipality of Rome. He also served as president of CIRF, the Italian River Restoration Center. He currently works at IRIDRA and serves as a technical director at Ambiente Italia, and is a senior consultant in a river ecologist for IRIDRA, author for more than 50 articles. So we are very, very honored to have you both here in the session today. So we are going to start first with Rob, who will provide insight from a conservation NGO perspective, focusing on the stormwater, green infrastructure, NbS for wastewater treatment, and the use of treatment wetlands for agricultural runoff. He will also discuss innovative smart NbS approaches that blend high-tech solutions in natural systems. While Giulio afterwards, he will discuss how treatment wetlands contribute to biodiversity based on findings from the MULTISOURCE project, while NbS, like wetlands and buffer strips, can enhance biodiversity. Their impacts depending on the design and natural features. So without further ado, Rob, the floor is yours.
All right. Yeah, no, thanks. It's good to be here. And I've been very absent from this project, I think. I feel bad as an advisory board member that I've missed several meetings, but it's good to join this. And I see a few faces like Fabio that I know. So yeah, I have just a few slides that I'm going to share. I realize, by the way, that my video is flickering in and out. This is something that's very specific to Teams and this computer, and no matter what webcam I use, for some reason in Teams it's doing this. So I may turn off my video while I'm sharing some slides just so it doesn't drive you all crazy, the flickering, but I'm still here.
Okay.
Let me see if I can share my screen. Let's see. Yes, share. Okay. Okay. Let me do this. Oops. I did it the other way. Okay. Can you guys see the slides now? Yeah?
Perfectly.
Perfect. Okay. So I'm going to just give you a kind of maybe an idiosyncratic perspective on my role at the Nature Conservancy and sort of the perspective from a conservation nonprofit. I'm going to aim for just maybe breadth rather than technical detail, which is dangerous with this group because some of you are technical experts. But I wanted to just, I thought that would be the most useful thing I could do is give you that NGO perspective. for those of you who don't know the Nature Conservancy, we're a large conservation nonprofit. You can sort of see our mission there. So we started as a biodiversity-focused land trust in the United States, and we now do lots of things that relate to freshwater quality, freshwater biodiversity, ecosystem services for people. And we now work in many, many countries. So you can sort of see the distribution of where we work on the bottom panel here. But still a big concentration in the Americas. Only a little bit of projects in Europe, so we're much less known for audiences like this one. But then a lot of work in Southern Africa and East Asia. So I mentioned that background because you can see that we focus on nature-based solutions. I'm going to talk about that today, often in contexts where there's a really strong biodiversity co-benefit, right? So that's sort of that history of us being a conservation organization. So there are other things that I think MULTISOURCE is talking about that are much more focused on, providing a service, treating wastewater, for instance, but have lower biodiversity co-benefits. And so those types of sanitation-focused projects, I would say the Conservancy has done a little bit less of. I work as lead scientist for nature-based solutions, as the introduction talked about. My background is as kind of an urban ecologist, urban planner, so you can see the kinds of stuff I work on the right. So really my only research, and this is why I feel nervous talking about this to this group, in sanitation and nature-based solutions was the same working group, the NatSans working group that Fabio was part of and others in MULTISOURCE were part of, that led to the IWA book that's on the lower left. So I'll mention sanitation and wastewater treatment by NbS just a bit in my remarks here, but that was a working group that I co-led with Catherine Cross. It was a lot of fun. I learned a lot, but it's not a strong focus of my research. Okay, I heard somebody say something. So since I don't have my video on, please speak up if someone needs to interrupt. So from the NGO sort of perspective, nature-based solutions for wastewater can mean lots and lots of things. I just wanted to put that out there. I think MULTISOURCE has a particular focus, but we are at the Nature Conservancy thinking about sort of all the issues you see on this slide when we're talking about nature-based solutions for water, and it could be for water quality or quantity or timing. And usually it's tied up with other social problems or governmental problems that you're trying to solve. So one of our biggest use cases is around sort of what are called resilient watersheds now, but in the past, the Nature Conservancy called water funds. So this is a really different use case, I realize, than what MULTISOURCE usually focuses on. This is at maybe the upstream end, and it's focused on drinking water quality. So the value proposition here generally is we're working with a water utility, and often the focus is on maintaining raw water quality. So that's reducing the treatment costs for the water utility. And so you can see a map on the lower right. Everywhere there's a circle is a place where we engage with the water utility on this topic. The darker circles are sort of some of our larger or more famous, more well-known water funds. So it's called a water fund because that's the financing mechanism. So that's another theme, I guess, of the Nature Conservancy's work is we are sometimes the technical service provider planning a nature-based solutions intervention or putting the shovel in the ground. But we're as often in the role of planning interventions and kind of financing them, creating the incentive structure to create them. So in the case of water funds, the utility is usually taking some of their money from their ratepayers and then investing in upstream watershed conservation that maintains their raw water quality. We do work in projects in this mode that relate to quantity. It depends a bit, though, on the land use in the watershed, if nature-based solutions interventions can really significantly influence the timing of water coming down the basin. So we see that kind of work a bit more in like Paramo systems or cloud forest systems. or places where there's a kind of a room for the river strategy and you're thinking about river timing. But generally water quality focused and a really clear value proposition. So we can say to a utility, if you reduce erosion by this amount, this is how much less often you'll have to dredge the reservoir. This is how much less you'll have to spend on treatment. So a lot of my science has been supporting this stuff. And just to me, it's really interesting mapping where the world's cities get their water from. So here I'm showing you Rio de Janeiro and Sao Paulo, and there are these very complicated supply systems, right? And some of my research shows that these supply systems are, if you wrapped all the canals supplying cities kind of end to end, they go around the world many, many times. Humans are moving water very long distances, and part of that is cities are trying to draw less dirty water to themselves, right? So they tend to go upstream of themselves to slightly cleaner water, and then they're transporting it downhill, so they don't have to fight gravity, to their city centers. So this sort of complex geometry, when you think about the return on investment of nature-based solutions for drinking water, is really important. The other thing that's really important is that all else being equal, small watersheds are easier to influence water quality in. And I think this is true in a lot of nature-based solutions types, actually. Smaller is easier. Smaller watersheds are easier in the sense that you can more meaningfully influence water quality and quantity. And large watersheds are hard for us to work at a scale where we can really drive significant difference in water quantity or quality. So just to give you a flavor of the kinds of work I do, here's some modeled output of sort of where agricultural best practices, for instance, can reduce nutrients. So we think a lot about how much intervention do we have to do with a certain strategy to hit different benchmarks, right? And then what's the return on investment for those sorts of benchmarks? So if anyone's into this, there's a report called the Urban Water Blueprint that kind of goes into this in detail. Okay, yeah, and so this shows you the kinds of results that came out of that report. Again, thinking about how many cities would actually, how many water utilities would get a return on investment that's positive from nature-based solutions for drinking water quality. How much space do you have to work in with one of the 5 techniques you see on the top here? So I hope that didn't feel like too much of a tangent from what I was asked to talk about. I was asked to talk a bit about kind of agricultural runoff, NbS solutions in agricultural systems. We do that. It's often in the context of the US Farm Bill, which has very strong incentives for implementing NbS and also reducing water pollution. And you see the same sort of thing, of course, in Europe and in Brazil. I wanted to highlight one specific experiment that I think is really cool. This has been going on for more than a decade, but there's a particular whole subwatershed. This is the Mackinac River, where we've been sort of concentrating all of our efforts at implementing the kinds of little constructed wetlands you can see in this drone picture on the left, and then trying to measure in a quantitative way over time what is the reduction in nutrient pollution. So you can see those on the right. And I think one big learning from this project, which maybe it sounds obvious in retrospect, is that in this landscape, there's a lot of tile drainage systems from agricultural fields. And so understanding all of the micro piping of those tile draining systems is really important for actually having nature-based solution features that do anything, because you have to route all of those little pipes into your constructed wetlands. But if you do that, it's quite a cost-effective system. So I think the challenge for agricultural NbS from the Conservancy's perspective is just that each of these interactions with farmers takes time, right? So there's transaction costs of talking to a farmer, educating them about what nature-based solutions can do, implementing the project on their site. And so when you're talking about a big basin like the Mississippi River, right, or the Rhine River Valley where I live now, getting outreach to that many farmers that you would need to influence the water quality parameters over the whole watershed is really hard. And so I think this is, from my perspective, again, a really big challenge for scaling up NbS is this question of how do you get around transaction costs and avoid institutions like the Nature Conservancy having to talk sort of one by one with landowners, but how could you generate incentives that would encourage many landowners to make a change on their own. We also do this same kind of agricultural work in really different contexts. So this is an example in Kenya. This is in the Nairobi watershed, so the Upper Tana. So it's a drinking watershed for Nairobi. It's one of these water funds I mentioned, but it's very agricultural, many, many smallholder farmers. And so here the interventions are quite simple, right? It's like cover crops, having riparian buffers along streams, etc. But the outreach, there's almost 1 million smallholder farmers in the Upper Tana. The outreach challenge is really, really challenging because there's so many smallholder farmers. So stormwater, I was finally getting to maybe the topic I was asked to talk about. In the US especially, but also in Germany and the United Kingdom to some extent, we work on green infrastructure and stormwater. This is a facility in Bridgeport, Connecticut, so the town near where Yale University is, if anyone knows that university. I like this particular example because it looks scruffy, but this is actually a community garden as well for the apartments you see in the back. So that is one theme of a lot of our stormwater work is getting these other benefits, whether they're social, like in this case, or sort of biodiversity co-benefits. In the US, this work is easier, and I would say it's easier in Europe as well, because you have strong incentives for clean water, right? And so when there is say a combined sewer overflow event and somebody's out of compliance with, say, the Clean Water Act, there are fines that are involved. And so all of the water utilities in the US, stormwater utilities, have a financial incentive to deal with their stormwater problem and their pollution problem. And I guess that's what gives value to green infrastructure, right? That's what makes our kinds of projects possible. This is another project we worked on in Philadelphia. Again, this is a park. It's supposed to be aesthetically beautiful, so there's a larger budget here for landscaping, but it's also serving that stormwater purpose. And this is a project in Washington, D.C. we worked on in a cemetery. So I thought I'd share this case with you. So this is Mount Olivet Cemetery in Washington, D.C. And so Washington, like many other places, requires landowners who are doing large construction or renovation to sequester all of the additional stormwater on site or to pay a fee. One thing that we've encouraged the District of Columbia government to do, which is a little different, is that there's a tradable stormwater retention credit market. So you can see this little schematic in the right. So if a landowner doesn't want to sequester that stormwater on site, because let's say they're building apartments in downtown Washington, D.C., where the land's really expensive, you might not want to set aside land for a rain garden. You can then buy a stormwater retention credit from another landowner who is creating that sort of green infrastructure. So one thing that the Conservancy has done in the capital of the US is take loans from banks, from impact investors. So they're willing to give us a slightly lower interest rate. And then we construct a bunch of green infrastructure like what you see on the screen here. And then we recoup that money by selling the stormwater retention credits on this stormwater retention credit market. So there's some challenges with this system. I'll be honest, again, transaction costs, we still have to work with landowners individually to set up these projects. There's also some interesting challenges that are hydrological, right? So there's a credit trading bubble within a city here, but of course, there's many subwatersheds within this city, right? And so what in effect you're doing is developing part of the landscape in one subwatershed and then generating stormwater retention credits in other subwatersheds. So that it's not a perfect system, but it's an interesting system. So the last thing I'll say is about smart green infrastructure. This is an increasing trend for us. And so the basic idea, we've actually kind of spun off a side company here called Brightstorm, is that in the US, where this work is focused, there's a lot of these just simple retention basins. You can see a picture here on the right. And classically, they're all sort of dumb, right? There's one weir height and then it just fills behind it. So all really we're doing with this system is integrating, you can see the schematic on the left, integrating in sensors of both the water levels in ponds like this, but also kind of cistern systems. And then also integrating that with weather forecasts, right? So what happens now, and we've done this in dozens of places, is when there's a big storm coming, like one of the hurricanes that now hit the US more frequently, in advance of that big storm, we will drain down these retention basins. And then obviously right before the storm hits, raise that weir back up, right? So you're basically maximizing stormwater capture. That's helpful for water quantity regulation and flow timing, but it also decreases nutrient pollution into some of these regulated watersheds like the Chesapeake Bay. And so every pound of nitrogen or kilogram of nitrogen that you avoid, or phosphorus that you avoid getting into the Chesapeake Bay, has an economic value. And so for the companies we work with on installing this sort of smart green infrastructure, it's helpful because they can recoup their investment fairly quickly, actually. So that was my little tour through at least how I and the Nature Conservancy think about NbS for water quality. I hope it was interesting, and I'll stop there.
Thank you very much.
Stop my share.
Thank you very much, Rob. Definitely is very, very interesting. You spoke about very, very important things that resonates a lot with many of the panel of experts that we have here in the call. You spoke about the co-benefits, which is one topic that I think some people here will be very interested about. Also, the water funds is something that is very much going to be talked about in the next COP16 at the end of this month in Colombia. So also another topic that some of you might be interested in. So please, for the public, like put your questions in chat or hold them for the discussion. But for the moment, we said thank you first to Rob, and now say welcome to Giulio. Thanks a lot for joining us. We know that you are on the road, but thanks a lot for making the time, and we are very appreciated for your time. So yeah, please go ahead, and if you need some support, please let us know.
Yes, hello everybody. Probably Anacleto will be, is going to show the slides, and so I will start soon. Even though IRIDRA, we are a small company, a small engineering company that design constructed wetlands, mainly those for many purposes, but mainly for pollution control, so what we call treatment wetlands. But today I will show some preliminary results of the work that is still ongoing, and concerning the relationship between this kind of wetlands and biodiversity, and how to measure it. So, Anacleto, if you can go on with the first slide, it's just a very general issue. All of us know that wetlands are reducing their surface since, let's say, probably in Italy since a few millennia nowadays, but let's say sharply in the last 300 years. So next slide, Anacleto. We in the last decades, wetlands start to be rebuilt. Sometimes, specifically, the wetlands are restored or built ex novo, just for the the same purpose, so for biodiversity. But most of the time, wetlands are built, as we also have seen by Rob presentation, for different purposes, such as stormwater control or pollution control. So in a highly anthropized landscape, like it is, for instance, in Europe, we may imagine that these wetlands can contribute also to biodiversity. Next slide, Anacleto. But we know that, yes, I think you can go to the next one. So among these different processes, treatment wetlands are by far probably the most diffused reason why wetlands are built, even I mean for different kind of water, because they can treat black water or gray water or mixed wastewater, or even stormwater or combined sewer overflow. So a mixture of stormwater and wastewater. And also the difference of the system could change a lot, as you see from this slide. I'm not entering into details, but on the next slide, you'll find the main two kinds of treatment wetlands that are diffused, that are the subsurface flow systems that could be horizontal or vertical, and the free water system. So the system where you have water flowing and you have direct contact between water and the atmosphere. And these last kind of wetland are by far the most similar to the natural wetland. So they are probably the most interesting from the biodiversity point of view. But do not forget that even subsurface flow wetlands have, I mean, they create an interesting habitat because they create reed beds. And there are, especially for some taxa, so specifically for birds, for instance, but also for insects, the kind of habitats that are created by subsurface flow can also be interesting. The main features for wetlands to be able to support biodiversity are, sorry, there is something, are the one indicated in this slide. So obviously, if you have free water, it is most likely more interesting, at least for a few taxa like amphibians and some species of insects like Odonata. And the size, we will see that this is a key issue. The location, so the possible disturbance by human activity, and as I said before, in the free-water wetlands, there are other important features like vegetation cover and bank slope, or specifically for a few kind of birds. So if we go on with the next one, we will. I will go very quickly through these few slides because I just put them just for you to go in details with the methodology we used, but mainly we are just presenting the first results of an activity that has been done on the bird community. And if you go on, if you Anacleto, if you go to the, not to the next, but to the, I mean, yes, this one is I have to mention it because the activity we have done, IRIDRA just supports the activity that has been done mainly by Roma Tre University and specifically by Matteo Guidotti, which is a young just graduate during this work. And if you go to the slide with the map, I will, which is probably the next, no, the next again. So this is the whole activity we have done. So for each, we selected 6 treatment wetlands and 3 semi-natural wetlands. And for each of them, we monitor the birds, the bird community in the wetland area and in a control area where no wetland was there. So I will not present the whole work because it is the data analysis is still ongoing. But if you go to the next slide, there should be the key elements. We just monitor the species richness. So we list all the bird species that was seen or heard by Matteo during his survey, and we listed it, and then we elaborate in species richness indexes and other 2 ecological indexes that are biodiversity indexes called Shannon and Simpson index. And here I will present just the results of the multi-source pilot area, which is the treatment wetland of Merone. You probably already know it, so I will very quickly go through its presentation. This is how the wetland appears. So there are 2 submerged flows where you have only reed beds, and then open a free water system with you see the small ponds at the south of the 2 larger submerged flows. So just in the next slide, you see just a very quick pictures of the areas, just to take the idea of what of where we made the survey. And if you look at the results, as I told you, species richness, Shannon index, and Simpson index, the difference between the Shannon and the Simpson is that the Simpson index consider both some species richness and evenness, but is focused on dominant species, so gives less importance to rare species, which means that his value can be higher if you have a lot of specimen of one single species. So in the next slide, you will see the results of the 2 surveys we done, the first one in autumn and the second one in spring. And you see that the most simple evidence we got is that in autumn, the treatment wetland has shows results that are not so different and sometimes are comparable with the ones of the semi-natural wetlands. So the next samples, the one in spring, the results were not so good, so were a little less performing than the semi-natural wetlands. So the a lot of other analyses are going on, and it will be published in the next months. But what we can say for the time being, it's that let's say that in some seasons, treatment wetland can provide support to biodiversity, even though in most likely the dimension, so the size of the wetlands, it is very important. And with reference to bird community, the loss of large wetlands is what we should try to compensate, creating large wetlands, at least more than 1 hectare. So these small treatment wetlands cannot really provide habitat for a series of bird species that requires larger habitat fractions. And what it could be interesting to understand is whether these small size wetland can be very interesting for other taxa. So we should work on amphibians and probably on insects that could be very interesting to analyze insect community, or at least a few taxa like in this area would be interesting to study odonata, so dragonflies. I'm sorry if my speech was not as good as I would like to have in my computer in front, but I did my best. Thank you.
No, Giulio, thank you very much, because this is a very interesting information and very enlightening also for many of us. It's very interesting how this work that you've done with this treatment wetland that some of us already visited is being performed. So it's very interesting how to see in like kind of like materialized way all this research that you are doing, and also very good point to further discuss which other type of species can be also analyzed in the future. That is also very interesting. But first of all, I would like to open the floor for questions in the public. Please take advantage of these two magnificent experts that we have. So please, if you have a question, please raise it up. Or in the meantime, if you kind of like to break the ice, I can make me start with the first one. Maybe for Rob, how can we balance, for example, the goals of water quality? In your case, you were explaining more about the drinking water, the quality of the drinking water, the sources that cities take these resources from. Which other way can we improve this access to this resource, but also having in mind the biodiversity conservation, also from the experience that you have seen in the TNC?
Oh, thank you. That's a hard question. It's hard because I think it's hard because so I think there's a theoretical answer, right, from environmental economics or something, where you want to have some value to all of the benefits you're getting from a piece of land, right? So some value for biodiversity, some value for the clean water, some value for whatever, human well-being, for recreation, etc. And then there's this theoretical framing that if those externalities were expressed, that people would make smarter decisions, right? I think in the real world, we end up cobbling together different programs, right? So for instance, in Brazil, there's a requirement around the forest code that a certain fraction of land is supposed to be forested, and there's a history of why that rule is there. But now many farmers are out of compliance with the forest code, right? And so there's this incentive to increase tree cover for those farmers. At the same time, you have some place like Sao Paulo wanting to protect their reservoirs. And so you have these different programs, one being payments from the water utility to prevent erosion, and then another, which is a state agency in Brazil trying to increase forest cover. But if you can kind of negotiate common purpose, then you can start to align those different programs, right? Or align planning. So I would say basins that have a legal structure for common kind of watershed planning make the kind of work we do a lot easier, if that makes sense, right? Because there's a forum to talk about, okay, here's the biodiversity benefits, here's the water quality benefits to different sectors. And if you don't have that forum for common planning, you have to sort of organize it. So going to the second talk that we just heard, like I think those biodiversity benefits are excellent that we were talking about for birds, and so one of the challenging things, like for us, is kind of if you're working with, say, a wastewater utility that might be considering constructing a treatment wetland, right? Like what benefits do they get from birds? Like why, or wildlife, like why should they factor that into their decision making? And maybe there might be, for example, like in the EU, there are payments now sometimes for creating grassland because grassland biodiversity is rare. So the question is like, to what extent does creating a treatment wetland, also qualify for those other kinds of biodiversity credits? Or you see in like the UK, there's now this new regulation about being net biodiversity positive, right? And so that's also starting to force companies to think about this issue. So as a long-winded answer to your question, I feel like in the real world, it's this complex mix of what are the regulations at different levels that companies or actors are responding to.
No, thank you very much. And yes, indeed. Yeah, Jamie, please jump in. No, yeah, that's the way. Yeah,
No,
this is a discussion.
I didn't mean, no, I didn't want to interrupt. Rob, right now you are actually based in Switzerland, is that right? And so, I mean, EU, non-EU, Schengen area. When you showed the map about all of the work that TNC has done, I mean, that's right. What you said, you've got the Americas, both North and South, really covered. You've got a lot of work in, kind of Asia and Africa. But if you look at the map of the EU, there's a lot that isn't covered. And I'm just wondering, like, since you're over here now, are there like upcoming activities, or are there projects, like are there local activities that TNC is supporting in this part of the world as well?
Yeah, so I've only been in Europe 3 years now, and I'm based near Basel, but I actually work for TNC Germany, so just about as far south as you can be in Germany. Yeah, so the historical reason we don't have as much activities here is just that World Wildlife Fund is so dominant in Europe, to be honest. And so they started in Europe, we started in the US, and we're friends, but also competitors in some ways. But I think we do, we have projects that relate to stormwater, certainly, in Stuttgart and Berlin, in Norfolk in the UK. And then we do a lot of work not related to sanitation, but related to dam management or freshwater biodiversity in southeastern Europe, so sort of in the Balkans. And that's been an intentional focus for us because there's just very high freshwater biodiversity there. Yeah, but we are expanding, and so we welcome discussions about other partnership. My job is to engage with groups like this and then think about what are key science partnerships for the Conservancy going forward. So I'm happy to talk with anybody.
Awesome, thanks.
Thank you. Anacleto.
Yeah, thank you. Continuing on the discussion with Rob, it was interesting to see all the different applications that essentially Nature Conservancy are facilitating, no? So from your presentation, what I understood best is that you are facilitating the introduction of green infrastructure to water sector in general. But still you are Nature Conservancy. So my question is it enough for you just to facilitate? So if they decide to go for a green infrastructure is okay per se, or do you require any double check or guidance to be sure that you have an impact in terms of biodiversity? Because for biodiversity and NbS or green blue infrastructure, what we are experiencing is a high demand of quantification, no, in business sector. So if I can fund whatever, but you have to prove me that you have an impact. And the interesting part of the demo in MULTISOURCE is to start understanding that there could be some trade-off to be managed in the design. And you cannot always claim, is it okay for biodiversity, and that's it. So which is the position of TNC? If you, for certain project, you require some detailed biodiversity monitoring or some particular aspect to be considered in the design or not of one of the examples that you presented?
Yeah, thank you for that question. So it varies, I guess, by project. We started as a land trust in the US, so we have about 1 million members in the US, and so a lot of what we do is buying land, preserving land, and sometimes transferring that over to governments to manage, right, as part of a national park system or something. But we do try to have money for biodiversity monitoring in that context, right, or to make sure the government agency who's going to monitor that property keeps up the biodiversity. But you're right, when you move to other kinds of interventions, the permanence is sometimes less monitored, and how you have to monitor it is a little less clear. So it sort of depends. Like some credits, like carbon credits, right? There's a defined system where you're supposed to monitor them, and we try to go above and beyond some of those standards, but to make sure you're actually providing the benefit you say. And certainly things like the stormwater retention credit system in DC, what's interesting in that case is that what you're certifying is that you're providing the credit, I think, for a 5-year window. So you're not promising you're going to provide stormwater retention forever, but during that 5-year window that you sold, you're legally obligated to provide that stormwater retention. Like it has to be functioning in terms of stormwater, and if you don't, then someone could come and sue you for not providing that stormwater retention benefit. But like we also try to make those stormwater retention facilities have a biodiversity benefit. Like we're just doing that because we want all our projects to have a biodiversity benefit, but there's no like regulatory requirement that we do that, right? And so then for us, it becomes for projects where then we have to fundraise for it ourselves. Do you see what I mean? Like, and so that's part of my job that's kind of challenging is, let's say we work on a bunch of stormwater green infrastructure projects. How do we find money to have someone go out occasionally and make sure they're healthy from a biodiversity perspective? That's more challenging. Yeah. And so this is going to change with other things. You talked about the corporate world. There is this interest in, which TNC is very skeptical of this term, but there's interest in sort of biodiversity credits and things like that. And so you can imagine some sort of scheme that requires monitoring of that, but it's not really in place right now.
Great, super interesting.
Just if I can bring an example, because I'm an hydraulic engineer, so I'm completely out of this discussion, and it's super interesting to me to dig into, because for instance, the most detailed example that I've seen, there is a sort of ISO for green roof, for biodiverse green roof, okay? And you can receive a rank that go from 1 to 4, something like this, if I remember well. To get the maximum, you should prove that in the design you have engaged biodiversity experts, so that the green roof was properly designed to meet a certain demand of biodiversity in urban landscape, let me say in this way. But from this super high level of detail, and the next score is you have to use at least certain minimum number of species, so to design biodiverse green roof. And there is a huge gap between designing with specific biodiversity purpose and just checklists that I have used different species. So this is telling us that the gray zone between being greenwashing, biodiversity washing, let me use this term, and to do proper design for also the biodiversity benefits still has a lot of gaps to be sustained, let me say, because I can claim that it's very rare that someone is really targeting biodiversity benefits with a clear demand of biodiversity in mind while designing it. So a lot of job for a future project, I think, Jamie, for this, and Rob.
Yeah, no, I mean, yes, for sure. And it's funny, these schemes, so we've engaged with like the LEAD scheme and other schemes where there are ways that you get points for being more biodiverse. And so that's one way that this value gets translated into biodiversity value gets translated into decisions that builders take. But then there's very little monitoring or enforcement, right? I mean, it's basically a checklist of practices, and there might be a certification at the front end, but they're not really tracked over time. Yeah.
Yeah, and just to give an example to comment that the presentation of Giulio is for doing that kind of monitoring, it's only one species, only birds. And Matteo Guidotti has to spend some months traveling around as an ornithologist. So monitoring biodiversity, it's complex, seriously, I mean, it's complex stuff. So, but it's also the possibility to open new green jobs to biologists and whatever. So I don't know if we are already ready in the water sector for this, but we need this kind of quantification approach to be serious when we claim biodiversity benefits. I mean, I don't know, Giulio, if you want to comment on this, because you were organizing the biodiversity monitoring of Matteo.
Yes, in this case, we were lucky to find a very good ornithologist that was just making his thesis and also wanted to go beyond it after his thesis. So, but what I think for these small wetlands, we can try to figure out something simpler, because, as I told you, birds are not probably the best taxa to the best taxon, the best group of animals, let's say, to monitor the effective performance. So with smaller ones, we may imagine something that could maybe can be done, maybe using citizen science, working on insects like butterflies or dragonflies. We have to work on it, most likely in a new project. We are going to do something to test something of that. But in general terms, I agree with Anacleto. It's quite costly to monitor biodiversity.
And maybe as a follow-up, from the species that you mentioned, Giulio, you mentioned like in the smaller wetlands, we should go for insects or dragonflies. But what about medium-sized animals? Like, I just forget the right biological, like roedor. I don't remember what is the correct English word for this.
An interesting group, obviously, is amphibians. So
Okay.
frogs and tritons. I think the English word tritons or salamander, or this kind of species that are in. We also imagine for Nerone to use this kind of to look for this kind of animals, but we could not find the possibility to do the surveys. I hope to organize it with the park, with Lambert Park, but it was not feasible in the end. But it is much simpler than with birds, because there are much less species, and they are easy to see them during the I mean in the from March to November, more or less. So that could be a possibility, and but obviously it can work only if you have free water systems. If you have only reed beds, you have to look for birds or insects because no amphibian will go there because there is no free water to go.
Great. Yeah, definitely. This is very challenging to scope which is the right species and what type of animals we are the ones that or these type of projects or in the environment and ecosystems that Europe has, for example, is kind of hard to identify. But in some other projects that I've been involved in, for example, yeah, amphibia is definitely one of the key species for biodiversity. Some mammals as well, and some rodents. But of course, it depends of the stereotype that the ecosystem has here. So yeah, this is very interesting, and I think we can go on for a lot of time discussing and what is improved or what is to be improved in this type of projects, especially considering the map that Rob just showed us. This is a lot to be done here in Europe. So this is kind of like an invitation for everybody to start thinking, what can we do in the future? What is also to be done, and what is interesting also from us, also from our perspective in MULTISOURCE, the work that we are doing. Some of us, some experts that sadly they are not here with us in the call, but co-benefits are one of the most interesting topics that we also want to talk about in the project. So this is going to be one of our next editions in the Splashdowns. So you are gonna receive more information about it in the future. We thank a lot for all your participation, the questions, the discussions. Thank you, Rob. Thank you, Giulio, for your time. This is a great discussion. Also, Anacleto, also thank you for the support behind the scenes. And thank you, everybody, for joining us. And you will get information soon of about our next Splashdown. So thanks a lot, and the discussion will continue.
Thank you very much.
Good
Bye.
to meet you all.
Bye-bye.
Bye-bye.
See you.
Bye.